So one thing I realised here looking at these planes, why it's quite handy to change the size of the plane and check it, is that I actually need the X direction to be pointing in the direction of this line. You can see here it's pointing away from it. And the easiest way to fix that is just to change the way that this line is created. So I can just flip this order around here, and now you see the X direction of the plane follows those radial lines. Okay, so let's just put this into a group, and we should give it a name, which is in the scribble. So call it set structural grid. Scrap that one, make it a group, and that one, more scribbles. This is the footprint. Let's add that to the group. This is the, in stadiums they call this the inner drip line or curve. That means it's the line on the ground where the roof potentially could drip water in. That's a strange technical term, but we'll use it. We've got our number of bays there. So now we're ready to look at bringing in this control curve here. We're going to do it in a slightly different way. In the past, we've just been referencing these in, but this is maybe a bit more robust. So from the parameters input, we can actually make a reference directly to a 3DM file, which means that we don't need the file open, but we're always going to be looking for it. So if I first of all just zoom in, what have we got here? Gives us a bit more control as well. So in the file that I have, the Rhino file I have, the Rhino file has got something called control curves. There's actually only one curve. You can see one curve. There's actually only one curve on that layer. And now this 3DM, import 3DM, lets us first of all set one file path. So we right click, can say we're going to use the Aviva control. Something didn't like that, but let's just carry on. And you can see straight away it's bringing in a load of different stuff, because what we can do is we can specify a layer name. So let's see what that layer is called. So if I right click on this and say set text, and it has to be exact. So if we put control curves, commit changes, now we can see the only curve that's coming in is that planar curve. Okay, so now we need to think about what this curve actually represents. So it represents the height of the roof above the drip line. Okay, so we want to think about how we're actually going to work with this curve. So what's nice now is that with this object I can set a new file. Don't want to save the changes. We're working here in millimeters. So my model still works. If I zoom out, here's the stuff that I've referenced in from that file. So I just got an untitled file making a direct reference to it. So it's a bit more robust. You know, it means that you don't have to have that file open. So what we're going to do with this piece of geometry is we want to get the endpoints, and between those endpoints make a line, a straight line. So that's my kind of reference line through there. And then that line we're going to divide it and we're going to use this. Is very important here, we use the same number of structural bays. So there we get our curve divided up, and then on each of those points we're going to make a plane which is the YZ plane, and we need to just check that is correct. Yeah. So you can see those. Let's just get the 3D view open so we can see, yeah, here those planes. And now what we want to do with those planes is intersect them with the curve, because this is going to give us the height of the roof. So we can do from the intersection menu in mathematical curve plane. So there's our imported curve, there's the plane. We get the results from that. What we're interested in those results, if you think about this, is we're interested in the Y value, so the height of those. So we can deconstruct those points to get access to the Y value. Let's put a group on there. Give it a scribble. This is reference to control curves. Add that to the group. Save the file. So the interesting thing about this super ellipse is that we're actually going to use the same curve definition for both the cross-section curves and the plan curves. So the next task now is that we're going to make some adaptations to this definition. So I'm going to grab this definition, make a copy of it, paste it. I'm going to drag it over here. I'm going to change this name to profile curves. Click on OK. And now we've got to think about how we're doing this, is that we're actually going to create one profile curve for every one of these sections. So we're moving into the next level. So previously we just created one super ellipse. So now we're actually going to create multiple super ellipses. And so the first thing we're going to do is add a new input right at the top. I'm just going to call it plane, and here we now have to say this is going to be a list coming in. So I right click on plane, we have to say what type of object, and here in the type hint we can say it's a plane, and the plane that we're making reference to, we're going to make reference to is these planes here. So I'm going to put that into there. Let's just move this down a bit so we can see that connection a bit better. Let's move. And so we'll go in and we're going to make some fairly small edits. We're going to keep the basic setup of the file the same, but we're going to create one new super ellipse, or 1/4 of a super ellipse, for every single plane, and we'll continue with that in the next video.